Do any of you want to retake that test? Did you want to retake that test? All right, we'll go ahead and get started. All right, make sure if you haven't picked up the packets up here, you do so before you leave. All right, just a reminder, your test number 2 is next week. Test 2 is next week. And I sent you a study guide, and it's also posted in Canvas. So make sure you're looking at that study guide. All right, so remember it's going to be from 6 to 7:45 p.m. Remember, those of you online, you may want to take it in class if you had issues last time taking it online. All right, one of the handouts you got was solving a system by elimination. So go ahead and take that out. Did you need to retake that test? All right, so on the last worksheet that you did, you had to solve a system using substitution. This time you're solving a system using elimination. Now substitution is on test 2. The elimination, what we do here, will be on test 3. So let's go ahead and look at some examples. So let's number 1. So this is section 9.1. Solving a system by elimination. Okay, so number 1, let's say we had this system. You had 2x plus y equal -3. Nope, that's not the one I want to put. Let me use this one instead. 2x minus 3y equal 4, and then x plus 3y equal -10. All right, so you have those two equations, and the directions will say solve the system by elimination/addition method. All right, did you do that retake? Yes. We talked about it last class period. Were you here last class period? You think? Okay, I also sent you 2 emails Friday and Monday about it. Let's see what. Let me see if you got that email.
Oh, the retake of the test. Yeah, no, I'm good.
You good? Okay. All right. Okay, so to solve a system by elimination addition, the idea is this. So you see the word addition, so at some point you want to add those 2 equations. And so you want to find out what x value and what y value will make this system a true system. What will satisfy the first equation and that second equation? The back thing with sitting in the back, Can you still see this? The monitors on the side aren't working. Can you still see this?
Yeah, I can see.
Okay. I asked the IT guy to meet me. He didn't show up. So hopefully he'll meet me next week. We always have issues with this technology. So he didn't show up. Asked him to meet me at 5:45. And I don't know everything. I put everything on like I was supposed to, and didn't come on. All right, so let's go through this again. So to solve a system by elimination addition, at some point, you're going to have to add those two equations. When you add the two equations, one of the variables will be eliminated. So what happens when I add those two equations? When I add those two equations, and you combine like terms, what's 2x and x? 3x. What happens to the y terms? Right, they're opposites, right? So they're eliminated. That's the idea of that elimination. So they're eliminated. And on the other side, what's 4 to negative 10? Negative 6. And then you get x by itself, and there's your solution for x. So we divide both sides by 3. I get x equals negative 2. So far my solution, my x value is negative 2. Now all I have to do now is find the y value. So to find the y value, you're going to go back to either one of those equations, does not matter. And where we see the variable x, what will you substitute? Negative 2. So it doesn't matter which one you go to. You tell me which one you want me to use. I'm not going to do both. You tell me which one. The bottom one, okay? So to find y, substitute x equal negative 2 into x plus 3y equal negative 10. All right, and so wherever you see the variable x, I'll substitute negative 2 and I'll solve for y. So here's what you get. You get negative 2 plus 3y equal negative 10. And then at that point, how do you get 3y by itself? What do you need to do to both sides? Add 2 to both sides. And then when you combine like terms, you get 3y equal negative 8. And then how do you get y by itself? Divide both sides by 3, and you get y to equal negative 8/3. So there's your y coordinate. So the solution to this system is negative 2, comma, negative 8/3. So that's the point. So if you were to graph this, remember there was a couple of lessons on graphing. Now you didn't have to do a worksheet on it, but there was a lesson on it. And where the two graphs intersect is a solution. So if you were to graph those two lines, they would intersect at what point? This point here, negative 2, negative 8/3, which is the solution. So if you want to check it, you can always check. So let's check and see that this is correct. All right, so let's go ahead and check this. So let's check negative 2, negative 8/3 is the solution. All right, so you go back to the original. Always go back to the original, which is this, 2x minus 3y equal 4, and then x plus 3y equal negative 10. So for each of those, where we see the variable x, I'll substitute negative 2, and where we see the variable y, I'll substitute negative 8/3. And I want to make sure that this equation and this equation are true at the same time. So let's look at that first equation. I have 2x minus 3y equal 4. So in place of x, I'll substitute negative 2. In place of y, I'll substitute negative 8/3. So I get 2 times negative 2 minus 3 times a negative 8/3. And I want to see if that's going to equal 4. Well, what's 2 times a negative 2? Negative 4. And then a negative times a positive. But what is 3 times 8/3? What happened to those 3's? What can I do with those 3's? reduce them. And so I get 4 plus what? 8, right? But then something is wrong. So let me did I write down the equation correct? 2x minus 3y equal 4, right? And then x plus 3y equal negative 10. Oh, I'm sorry. 2 times negative 4 is not 4. What's 2 times negative 4? Negative 4. Okay. Plus what?
2
8.
times negative 4 is negative 8.
Yep, thank you. And so negative 4 plus 8 is 4. All right, so negative 2, negative 8 thirds is a solution to the first one. Now we got to verify for the second one. So the second equation, you have x plus 3y equal negative 10. And so x, remember, is negative 2, and y is the negative 8 thirds. So I have negative 2 plus 3 times negative 8 thirds, and I want to see if that's going to equal negative 10. Well, the 3's divide out, so I get negative 2 plus, and then what's 1 times a negative 8? What's this right here? And when you add them up, what do you get? Which is what you wanted, all right? So the point that satisfies both equations at the same time is negative 2, negative 10. So if you were to graph them, they would intersect at that point. All right, but that's the idea of the elimination addition. So remember, the elimination addition, at some point when you add those two equations, one of the variables has to be eliminated, okay? All right. The one in your test on test 3 and on the final exam, and they usually have one on the final exam, will not be this simple. So the idea is to get you to the idea of what we mean by elimination addition. So let's do another example, one where you have to do a little bit more work. So number 2. So let's suppose in number 2, I have this equation, 2x plus y equal negative 3, and then negative 3x minus 2y equal 4. So 2x plus y equal negative 3, and negative 3x minus 2y equal 4. First of all, can I add those equations right now? No. Why can't I? Now, I can add them, but is that going to help me? No, the whole idea for adding them is to do what? When I add them, what do I want to happen? One of the variables have to be eliminated. And when I add them, that's not true. What's 2x and a negative 3x? Negative x, right? What's y and a negative 2y? Negative y. No variables were eliminated. All right, so that's where we have to use that handout. All right, so step 1, make sure all your x's and y's are aligned, and they are. So you have on one side you have your variables, on the other side you have your constants. Step 2, look to see if one variable has opposite coefficients, just like number 1 did. In number 1, did you see that one variable had opposite coefficients? The y's, right? A negative 3 and 3. But in number 2, you don't see that. The coefficients of x are 2 and negative 3. Those are not opposites. The coefficient of y's are 1 and negative 2. Those are not opposites. All right, so if yes, you move to step 3. That's where you would add them. That's the easy kind. If no, then here's what you want to do. You want to multiply one or both equations, one or both, by a constant, which we'll call the least common multiple, in order to make the coefficients of the x or y terms opposites. So here's what you got to think about. You got to decide, do you want to eliminate the x's or do you want to eliminate the y's? Does not matter. But look to see which one will make things easier on yourself. Is eliminating the x's going to make things easier than eliminating the y's? Okay, you say no. Why not?
You have negative 2 and 1. So
Very good. See, the coefficient here is already 1. And so if I look at 1 and negative 2, what's the least common multiple of 1 and negative 2? 2. So this one's already a 2. All I got to do is make this right here, what number? A positive 2. But what I got to do to get that to be a positive 2 is I've got to multiply the left side and the right side by what number? 2. Okay? And now when I do that, look at what I get. So I'm going to put a little arrow here to just show you that I'm going to rewrite those two equations. And when I do that, what's 2 times 2x? 4x. What's 2 times y? 2y equal, and what's negative 3 times 2? Negative 5. I'm sorry, negative 6. Thank you. Now remember, what you do to one side, you have to do the other. Some students forget about the other side. And then did I do anything with that second equation? No, just rewrite it over. All right, now can I add them? Yes. Now you can add them. And when I add them, what variable is eliminated? The y. So what's 4x minus 3x? And then what does x equal? And so there's your x coordinate, your solution. So my solution, your x coordinate will be negative 2. Now you have to find the y coordinate. So to find the y coordinate, you go back and substitute negative 2 into one of those other equations, into one of those two equations. All right, so which one do you want to go back to? So to find y, substitute x equal negative 2 into, which one do you want to use? The top one. Because look, it's easier to solve for y because the coefficient of y is already 1. All right, so I get 2 times negative 2 plus y equals negative 3. 2 times negative 2 is a negative 4, so I get negative 4 plus y equals negative 3. All right, now how do I get y by itself? Add 4 to both sides. And the 4s are opposites, that's 0. 0 plus y is y. So what does y equal? No, be careful. Negative 3 and 4. Negative 3 plus 4.
1.
Yeah. So negative 3 plus 4. So the solution is negative 2, 1. And you can always check, right? Now, I'm not going to have time to check all of them because I'm going to run out of time. But you can always check this, especially when it's on a worksheet. You have time to check on a worksheet. So to check, go back to the original equation. So you had those two equations, 2x plus y equal negative 3, and then negative 3x minus 2y equal 4. So in place of x, you'll substitute negative 2. In place of y, you'll substitute 1. So I have 2 times negative 2 plus 1. And the question is that equal to 3? Well, what's 2? I'm sorry, negative 3. What's 2 times a negative 2? And what's negative 4 plus 1? Negative 3. Do the same thing here. Negative 3 times x. X is negative 2. Minus 2 times y, which is 1. And you want to see if that's going to equal 4. What's a negative 3 times a negative 2? And then, so that's 6 minus 2, and that is equal to what? 4. Okay? So remember, though, we eliminated the y's, right? Someone else could have said, could we eliminate the x's instead? Sure. So let's do the same problem, but this time let's eliminate the x's. So the same problem. So number 2 again, and then it was 2x plus y equal negative 3. And then negative 3x minus 2y equal 4. All right, so let's suppose that you want to eliminate the x's instead. So the coefficient is 2 and negative 3. What's the least common multiple of 2 and negative 3? What's the smallest number that 2 and negative 3 go into? 6. Okay, 6. Now remember, when you add them, those coefficients have to be opposites. One has to be positive, the other one has to be negative, which I already have that, right? I have one positive, the other one what? Negative. But all I got to do is just make sure this right here is a 6, and this is a what? Negative 6. So we're going to multiply both sides here by 2 times what is 6? 3. And then both sides here by what? 2. All right, you understand this? Okay? All right, and then let's get rid of the parentheses so we can distribute. And so this becomes, what's 3 times 2x? What's 3 times y? Equal, and what's negative 3 times negative 3? I'm sorry, negative 3 times 3. And then the second equation, 2 times negative 3x. 2 times negative 2y. Equal, and then what's 4 times 2? 8. Now can I add them? Yep. So when I add them, the x's are eliminated. And 3y and a negative 4y is negative 1y, right? Equal a negative 9 plus 8 is negative 1. And then how to get y by itself? Divide both sides by negative 1. And so therefore, what's y? 1, which is what we knew it was supposed to be. And then to solve for x, you go back again to one of those equations and you substitute in place of y, you substitute 1. So to solve for x, we're going to substitute y equal 1. Which equation do you want to use? It does not matter. The top one, so 2x plus y equal negative 3. All right, so y is 1, right? So 2x plus 1 equal negative 3. What's the next step? Solve for x. Subtract 1. Combine like terms, I get 2x equals, what's a negative 3 and a negative 1? So therefore, divide both sides by 2, what's x? Negative 2. Okay? Now the directions, remember the directions will usually say write your solution as an ordered pair. So an ordered pair is a point. So you're going to say this, you're going to say solution parentheses, what's the x coordinate? Make sure you put it in correct order. Negative 2. And what's the y coordinate? 1. So make sure you put them in the right order. So elimination addition. All right, let's do another one. All right, so this will be number 3. So let's suppose in number 3 you have let's see. All right, let's just do this. 5x minus 3y equal negative 1. 3x plus 2y equal 7. So that is a 3x right here. 3x plus 2y equals 7. Is adding them going to help me right away? No. So you got to determine which variable do you want to eliminate. It does not matter. You have to find the least common multiple. Huh? The y's? Why did you want to eliminate the y's and not the x's? It doesn't matter. But why did you choose the y's? All right, because one of them's already negative, the other one's already positive. Okay. Yeah, let's go ahead and do the other one just to show you what you would do. So let's go ahead and eliminate the x's. All right, you got to find the least common multiple. So what's the least common multiple of 5 and 3? Meaning, what's the smallest number that 5 and 3 go into? 15. So you want this number to be a 15 right here, right? This coefficient. So I'm going to have to multiply that 5 by what to get 15? 3. So both sides will have to be multiplied by 3. I want this to be a 15 as well, but we're going to talk about the opposite in a little while. But I want this to be a 15 as well. So 3 times what's 15? 5 though, right? 5. Okay, I'm going to come back to the negative. But remember, I'm going to get 15 for both cases, both coefficients, but when I add them up, 15 plus 15 is not 0. 15 plus 15 is 30. So I need one of them to be negative, right? Does it matter which one is negative, the 3 or the 5? Does not matter. You said -5, so I'll put -5 here. You have to make one of them negative though, because one has to be positive, the other one has to be negative, for those are the opposites. All right, distribute. Let's see what we get. 3 times 5x. 3 times a -3y equal -1 times 3. Okay. -5 times 3x. -5 times 2y equals 7 times -5, -35. Now can I add them? Yes. So when you add them, the x's are eliminated because 15x and a -15x is 0. But a -9y and a -10y is a -19y. Equal -3 and a -35 is a -38. And dividing both sides by -19, what's y? 2. So I found the y coordinate of my solution. So the solution, remember they're going to ask you to write it as an ordered pair. Make sure you put 2 in place of the y coordinate. Now we just got to find the x. So to find the x, you're going to substitute y equal 2 into one of the original equations. Tell me which one you want to use. Does not matter. The top one? Okay. All right. So to find x, you're going to substitute y equal 2 into 5x minus 3y equal -1. All right, so wherever I see a y, I'll substitute 2. All right, so I get 5 times x minus 3 times y, which is 2, equals -1. What's a -3 times 2? -6. You get 5x minus 6 equal -1, right? Adding 6 to both sides, 5x equal -1 plus 6 is 5. Dividing both sides by 5, what is the x coordinate? 1. So my solution is 1, 2. All right, so that's the idea of elimination. Okay. 4. 5x plus 12y equal 11. 3y equal 4x plus 1. So 5x plus 12y equal 11. 3y equal 4x plus 1. What's different from number 4 versus the other 3? The x's and the y's are not aligned. So remember step 1, if you go back to step 1, it says line up the x's and the y's. So I'm going to bring that 4x to the other side. So when I do that, I get 5x plus 12y equal 11. And do y'all agree that this is going to be a -4x plus 3y equal 1? Okay. So which variable do you want to eliminate? Let's go ahead and eliminate the y's. So if I look at y, the coefficient of y, 12 and 3, what's the least common multiple of 12 and 3? 12. So the first one's already 12, right? I just got to make sure that the coefficient I'm circling right here is a -12. So what do I need to multiply both sides of that bottom equation by? 3 times what is a -12? -4, yes. Yep, -4. Okay. If you had chosen the x's, what would be the least common multiple for the x's? Was the smallest number that 5 and -4 go to? 20. All right, so then when you do that, you get 5x plus 12y equal 11. Negative 4 times a negative 4x is 16x. A negative 4 times 3y is a negative 12y equal, and then 1 times negative 4 is a negative 4. Now can I add them? Yes. What's 16x plus 5x? 21x. The y's cancel out. Equal. What's 11 minus 4? 7. Dividing both sides by 21. And then reducing. I get x to be 1 divided by 3, so 1/3. So there's your x coordinate. So the solution will be 1/3, comma. Now I've got to find what y is. All right. So we have a fraction this time, so you have to deal with fractions. You had fractions in worksheets before. So to find y, we're going to substitute x equal 1/3 into, all right, which equation do you want to use? Top or the bottom? The original. Always go back to the original. The bottom? The top one? You want to use the top one? We can use the top one. I would have, to be honest with you, I would have chosen the bottom because 3y is already by itself. Yeah. 3y is already by itself. So 3y equal 4x plus 1. So in place of x, substitute 1/3, right? So I get 3y equal 4 times 1/3 plus 1. What's 4 times 1/3? What fraction is 4 times 1/3? 4/3, right? So I get 3y equal 4/3 plus 1. All right, now remember you're dealing with fractions, so here's the best way to do this. The best way to do this is to add the two fractions that are on the right first. So 4/3 plus 1, what's the least common denominator of 4/3 and 1? 3. So I get 3y equals 4/3 plus 3 divided by 3, right? So what's 4/3 plus 3 divided by 3? 7/3. I get 3y equals 7/3. And then let's remember something from a few semesters ago. How to get y by itself? Divide by 3, right? Just like this. 3 divided by 3 is 1. 1 times y is y. But you got to remember this. Whenever you are dividing a fraction by another fraction, how do you deal with that? Change it to what kind of problem? Multiplication. You change the multiplication problem. So whenever you have a fraction divided by another fraction, you're going to take the top fraction in the numerator, which is 7/3. You're going to multiply it by the reciprocal of that bottom fraction. What's the reciprocal of 3? 1/3. So what's the answer? 7, not 7/3, 7/9. 3 times 3 is 9. And there's your y. So 7/9. So the solution is 1/3, comma, 7/9. Okay? All right, so that is elimination addition. Now, there were two worksheets on that you picked up. Those of you online, you have to go to the Canvas course to look at those two worksheets. So the first one that you picked up, we talked about already. So those three problems, you're going to work them just like we did these problems here. But if you go to the next one, now remember that one's graded. The first sheet says graded. If you go to the next one, it's still section 9.1, but this one's not graded. So this worksheet talks about how to classify systems. And so it's not graded, so the key is already posted, but I'm just going to do one or two examples just to get you an idea. But the key's already posted, the lessons are there, so make sure make sure you're looking at the key and the lessons that go with this worksheet. So let's look at this example. Let's suppose we had, and this is going to be number, still dealing with systems, so let's call it number 5. We have negative x plus 3y equal 9, and then 2x minus 6y equal 12. All right, so you tell me which variable you want to eliminate. Does not matter. You tell me which one to go with. Pick one. Which one?
X's.
The x's? All right, so if I look at the coefficient of x, one's -1, the other one's 2. What's the least common multiple? 2. So the second equation already has 2. So the first one, I'm going to have to multiply by what to get this -2 that I need? 2. And so now I'm going to get 2 times negative x is a negative 2x. 2 times 3y is 6y equal, that's supposed to be a y here. That's supposed to be a y, equal 18. The second equation, 2x minus 6y equal 12, right? Now, when I add them, what do you notice when you add those two equations? Both variables cancel out. So this is 0, this is 0. So the left-hand side, 0 plus 0 is still what? 0. And that's equal, what's 18 plus 12? 30. Is 0 equal to 30? That's a false statement, right? So that's a false statement. So what that means, I remember the variables disappeared. So what that means, since that's a false statement, is that this system has no solution. So this system has no solution. So you're going to say no solution. So if you were to graph those two lines, now remember when you're solving a system, when you look at those lessons, one of several things could occur. The two lines could intersect, and where they intersect, that's a solution, right? So I'm going to ask you, for number 5, would those two lines intersect? Yeah, because we just said there's what? No solution. Or the two lines could overlap, in which case there will be an infinite number of solutions. Is that what I have here? No. So the only other possibility is that the two lines are parallel. So those two lines, if you were to graph them, those two lines would be parallel. They have the same slope, different y-intercepts. So that's what you have here. So the two lines would be parallel. They don't intersect, so there's no solution. Now, whenever you look at that, the key to that second worksheet that's not graded, they talk about a system that has no solution. We call that an inconsistent system. So the system we say is inconsistent. It has no solution. All right, and then let's do one more. Let's look at number 6. All right, number 6, you have 3x minus y equals 7. 6x minus 2y equal 14. All right, which variable do you want to eliminate? Adding them is not going to help you right now. Doesn't matter, just pick one. Okay, if you want to pick x, then what's the least common multiple for 3 and 6? 6. So this equation already has 6 here. I got to get this to be a -6. So what do I need to multiply both sides of the top equation by? -2. All right, and so now when I distribute, I get -2 times 3x is -6x. -2 times the negative y is a positive 2y equal 7 times negative 2 is a negative 14. And then 6x minus 2y equal 14. Now can I add them? Yes. But notice when you add them, the x's cancel out, the y's cancel out, 0 plus 0 is still 0 equal, what's negative 14 and 14? 0. So this time, what do you notice about that statement 0 equals 0? That's a true statement. Okay, what that means is that, so remember in the first, for example, how many solutions did those systems have? Just one. In that example number 5, how many solutions did that system have? None, didn't have any. In number 6, this system has an infinite number of solutions. It has an infinite number of solutions. Now that's how, when I say what are the solutions, don't say it's an infinite number, but that's what it is. It's an infinite number of solutions. What that means, if you were to graph them, which of those graphs that we talk about applies here? The one right here, the one where the two lines overlap. So the two lines overlap is where you have an infinite number of solutions. But then the question is, how do you write it? Well, so just to show you, when I say it's an infinite number of solutions, I don't mean that just any point in this coordinate plane is a solution. That's not what I'm saying. What I'm saying is that this system has an infinite number of solutions, meaning that if I were to graph those two lines, and I don't know what it looks like, I'm just drawing them, those two lines intersect and the solutions would be on the line that overlaps. Okay? So all these other points here would not be solutions, right? But y'all agree that this is still an infinite number of solutions right here, correct? Okay. But then how do you write it? Well, it depends on the textbook. So I think on the lesson that you have for that, you write the solution like this. So you can write it as a set builder notation. Set builder notation. So you're going to say this. You're going to say the set of ordered pairs xy, the set of ordered pairs xy, such that, this symbol right here means such that, and then all you do is just give me one of those equations, the top one or the bottom one, such that 6x minus 2y equal 14. And that's it. You could have used the other one if you wanted to. But whenever you have an infinite number of solutions, you're going to write it like that. Now, if I asked you, if I said, go ahead and find one of the solutions, there's an infinite number, right? All right, so I'm going to ask you this. I'm going to say, find one of them. What would you do? How'd you find one of the solutions? Yes, you know. How would you find one of the solutions? Pick a value for x and solve for y. It's like doing a t-table, right? Give me a value for x. What's the easiest number to use for x? 0. So if x is 0, let's solve for y. So I'm going to go back to my equation. 6 times 0 minus 2y equal 14. 6 times 0 is 0, right? So I get negative 2y equal 14. So what's one of your solutions? Well, what's y first of all? Negative 7. So one of your solutions is 0, negative 7. So 0, negative 7 would be on the y-axis. So this would be the point 0, negative 7. What if I ask you to find another one? Give me another value for x. 1. If x is 1, go back to your equation. 6x minus 2y equal 14. 6 times 1 minus 2y equal 14. 6 times 1 is 6. So 6 minus 2y equal 14. What's the next step? Subtract 6. So I get negative 2y equal 8. And so what's y? -4. So your other solution is 1, -4. So let's say this is 1, -4 right here. 1, -4. So you know how to find solutions to this system that has an infinite number of solutions. Now we call, and when you look at the lesson that goes with that worksheet that's not graded, we call this system, the system that overlaps, the equation that overlaps, we call that a dependent system. So the system is dependent. Now I'm not going to ask you on a test or a quiz to tell me whether it's dependent or inconsistent or anything like that. But just know that those words exist, and they could ask you that in Newton Alta. All right, so any questions on 9.1? All right, that's 9.1. So on your test, your test number 3, not test number 2, test number 3, you are going to have to solve a system by elimination addition. Test number 3. All right, now the next thing I want to look at is okay, so all right, do you see the one that says section 2.4 worksheet 3? Okay, that's a section on circles still. So you had some worksheets last week that dealt with circles. This is going a little bit further with the idea of circles. Okay, so let's look at this. It's not difficult. It is not difficult. So section 2.4, worksheet 3, dealing with circles. All right, now, do you remember the standard form of the equation of a circle? What does that look like? The standard form of the equation of a circle. X minus h squared plus y minus k squared equals r squared, right? Okay. So let's look at this example. All right, so let's suppose we had this. Number 1, a circle has diameter. A circle has diameter with the following coordinates. And let me call them endpoints, with the following endpoints. And the endpoints are 3, -3, and 1, 5. 3, -3, and 1, 5. Now, let me, if sometimes it helps if you kind of in your mind visualize what this looks like. So if you were to put this in a coordinate plane, so 3, -3, 1, 2, 3, 1, 2, 3, -3 is right here, and 1, 5 is right here. So remember, this right here is the diameter, right? And so if you look at that circle, I'm not doing a very good job drawing a circle, you get something that looks like this. Let me just extend it. So this is 5 right here. All right? So you want to find the equation of a circle. If you're going to find the equation of the circle, you need to know 2 things. What 2 things must you know? You had this in the worksheet that was due last week. The center, you have to know the center, must find the center. And what else must you know? The radius. You don't know any of that here. All you're given is that you have a circle that has diameter with those endpoints. The endpoints being 1, 5 and 3, -3. So you got to find the center and you have to find the radius. But if you recall, probably about 2, 3 weeks ago, maybe 3 weeks ago, there was a small little section that talked about finding midpoint and distance. Remember that? Midpoint and distance. You're going to use that here. Now, I'll give you the formulas on a test, and you're going to have one on test number 3 like this. But you got to remember I'll give you the midpoint formula, but remember the midpoint formula is this. That's where you add the x coordinates together and divide by what number? Midpoint, middle, mid, you divide by what? 2. You do the same thing with the y coordinates. y1 plus y2 divided by 2. And then the distance, remember the distance formula? The square root of, and then you subtract the x coordinates from each other, x2 minus x1, and you square that. And then subtract the y coordinates from each other, y2 minus y1 squared. So you had that in a previous lesson, and I think you had a worksheet on that was due as well. So midpoint distance. So I'm going to ask you, how can I find the center of the circle? What do you remember about the center of a circle? The center of a circle always lies on a diameter. In fact, the diameter always goes through the center, right? So if I have a circle, and this is the center right here, all of these diameters must go where? Through the center. So a circle has how many diameters? An infinite number. So if I'm given the diameter, how can I find that center? How can I find this point right here? This is going to be the center of the circle. The center of that circle happens to be what part of the diameter? The midpoint. The center of the circle is the midpoint of the diameter. So I now know how to find the center. So let's find the center. So the center is the midpoint of the diameter. So the center equals. Okay, so let's call this right here, I'm going to call this x1, y1, x2, y2. So the center, you add the x's together. So what's x1? 3 plus x2, what's x2? 1. Divide by 2, comma. y1, what's y1? -3 plus 5, all divided by 2. Now let's simplify this. What's 3 plus 1? What's 4 divided by 2? 2. What's -3 plus 5? 2. 2 divided by 2 is, there's your center. So the center is 2, 1. So the center of that circle is 2, 1. So now I know the center. So the center is always the easiest to find. Given the diameter, you use the center is the midpoint of the diameter. So use the midpoint formula. All right, but now we got to find the radius though. So remember, the radius, what's the relationship between the radius and the diameter? It's half, the radius is half the diameter, right? So there are a couple of ways you can find the radius. All right, I want you to look at this. I want you to think about this. I can find the radius by looking at the length of the diameter and then dividing it by what number? 2. Or I can find the radius by finding the distance between the center and one of the endpoints. Doesn't matter which one, does it? But here's a problem. I could have messed up with the center, right? So it's always best to find the radius by finding the length of the diameter. Because I could have gotten this wrong right here. And then your radius would have been wrong even further. All right, you understand? All right, so let's go ahead and find the length of the diameter. So the radius is going to equal the length of the diameter divided by what number? 2. All right, and all I got to do is find the length of the diameter. How do you find the length of a segment? Using what formula? The distance formula. And so you know your x1, y1, and you know your x2, y2. So let's go ahead and find the length of the diameter. So x1, x2. What's x2 here? Nope. Oh, yes, thank you. X2 is 1. Thank you. 1, subtract x1. What's x1? 3. What do I do with 1 subtract 3? What must I do to it? Square it. Plus y2. What's y2? Y2 is up here. It says it, right? Y2 is what? 5. Subtract y1, which is a negative 3. What do I do to that? Square it. Whatever all that is, though, I've got to divide by 2. All right, so let's go ahead and simplify this further. What's 1 subtract 3? Negative 2. And what do I do to that negative 2? Square it. Plus, what's 5 subtract the negative 3 the same as? 5 plus 3, which is 8 squared. All that's being divided by what number? 2. Equal. What's negative 2 times itself? What's negative 2 squared? 4. And what's 8 squared? 64. All that being divided by 2. What's 64 plus 4? 68. All that being divided by 2, right? Okay. So you found the length of the radius. The radius is the square root of 68 divided by 2. Now, on a previous worksheet, you had to simplify radicals, correct? But don't do that here because all you want to know is the equation of that circle. You just want to find the equation of that circle. So the equation of the circle, you now know the center and you now know the radius. So the equation of the circle, watch how simple this is. Equation of circle. Remember, it's x minus h squared plus y minus k squared equals r squared, right? Okay, what's h? Remember, the center is 2, 1. So 2 represents which letter? H. 1 represents what letter? K. So I have so far x minus h. What's h? 2 squared plus y minus k. What's k? 1 squared equal the radius. What's the radius? Square root of 68 divided by 2. But what must I do to that according to the formula? Square it. All right, one more step and you're done. So the answer will be x minus 2 squared plus y minus 1 squared equal. All right, now let's go off to the side and figure out what the square root of 68 divided by 2 times the square root of 68 divided by 2 is. Well, first of all, what's the square root of 68 times the square root of 68? Right away, what is it? Without using a calculator, what's the square root of 68 times the square root of 68? 68. The square root of 5 times 5 is just what? 5. Square root of 25, which is 5. The square root of 7 times the square root of 7 is 7. The square root of 4 times the square root of 4 is 4. The square root of 68 times the square root of 68 is 68. What's 2 times 2? Now, on your calculator, I think that's going to be a whole number. It's going to be what? 17, is that correct? 68 divided by 4? What is 68 divided by 4? 17? All right. So I guess 17. There's the answer. Now, it's quite a bit of work and a lot of thought process you have to go through there, a lot of things you have to remember. Okay. All right, so on that first problem, that worksheet that's due, number 1 says a circle has diameter with the following endpoints. Find the center of the circle. You now know how to do that. You're going to use what formula to find the center of the circle? Midpoint. Then you can find the length of the radius. You now know how to do that. You're going to use the distance formula. So you can find the length of the diameter divided by 2. And then part C, you find the standard form. All right, so let's look at something that looks like number 2. All right, number 2. All right, so let's suppose we had this. A circle has center 8, -2, and contains the point -1, 4. All right, you want to find the standard form of the equation of a circle. All right, so in the first problem, you were given the diameter. So in your mind, it helps to visualize this in your mind. So in your mind, this is what you have. You have the center, which is 8, -2. So let's say that's about here, 8, -2. And it contains the point -1, 4. So -1, 4, let's say, is here. All right, now remember, when I say it contains the point -1, 4, what that means is that, remember, that's the center, right? So what that means is that when I draw that circle, and I'm not doing a good job drawing the circle, this is the center, y'all agree? So when I say it contains the point -1, 4, it means that -1, 4 is on that circle. That's what that means. Okay? All right, now remember, in order to find the equation of a circle, you have to know 2 things. You must know the center, and what else must you know? The radius. Do you know any of them? Yes, you know the center. Right away, you know the center. Number 1, you didn't. You had to find it. Here you do. What's the center? 8, -2. Do you know the radius? No, but you can find it because y'all agreed that the now remember the circle has an infinite number of radii, but y'all agree that this is one of them right here. And so to find the length of the radius, I know this endpoint and I know the center. The center is 8, -2. So how can I find that red segment, the length of that red segment? The distance formula. The distance formula. Now, it's not the diameter, but if it was a diameter, I would divide by 2. Here's just a radius. So do I need to divide by 2 like I did number 1? No. So the length of the radius, then the radius would be the square root of, I'm going to use x2 minus x1 squared plus y2 minus y1 squared. And so let's call this x1, y1, and this, let's call it x2, y2. All right, so let's go ahead and find the length of the radius. Square root of, what's x2 here? 8. Subtract x1, what's x1? What do I do to that? Square it. Plus y2, what's y2? Subtract y1, which is 4. What do I do to that? Square it. What's 8 subtract -1? And what's 9 squared? 81. Plus, what's 2 subtract 4? And what's -6 squared? 36. And what's the square root of 81 plus 36? What's 81 plus 36? 107? I mean, 100, 17? Okay, so there's a radius. Just using the distance formula. And now we have enough information to find the standard form. So the standard form, remember, the standard form is x minus h squared plus y minus k squared equals r squared. So what's h in this case? What number represents h? 8. What number represents k? -2. All right, so I get x minus h, which is 8 squared, plus y minus k, which is a -2 squared, equals the radius. What's the radius? Square root of 117. But what do I do to the square root of 117? Squared. Now let's go ahead and simplify this. So that's going to be our answer. The next thing will be our answer. So I get x minus 8 squared plus y subtract -2 means y plus 2 squared equal. And what's the square root of 117 times itself? 117. So there's your answer. All right. Not difficult at all. Quite a few formulas you have to use. But notice it does help to visualize the diagram for these when you're dealing with those circles. It helps to visualize it. All right, number 3. All right, find the equation of a circle in standard form whose center is -4, 5 and has diameter square root. All right, and has diameter square root of 6. All right, so if you're going to find the equation of a circle, what 2 things must you know? The center and the radius, right? I know the center. What's the center? -4, 5. So there's my h, there's my k. I don't quite know the radius. I know what part of the circle though, the length of the diameter. So from there I can find the radius, the length of the radius. The radius is the diameter divided by 2. Well, what's the diameter here? Square root of 6, so that's square root of 6 divided by 2. Now don't say 6 divided by 2 is 3, because that's not 6 divided by 2. That's the square root of 6 divided by 2. And that's not the square root of 3. All right, so now we're going to substitute into the formula. X minus h squared plus y minus k squared equals r squared. So I get x minus h, what's h? -4 squared plus y minus k, what's k? 5 squared equal, now what's the radius? Square root of 6 divided by 2. What do I do to that? Square it. So now the answer will be x plus 4 squared plus y minus 5 squared. And then I got to go off to the side and figure out what that radius squared is. So square root of 6 divided by 2 squared means the square root of 6 divided by 2 times itself. What's the square root of 6 times the square root of 6? 6. What's 2 times 2? What's that reduced? 3/2. So there's your answer. Okay? So that's the equation of a circle. And then finally, number 4. All right, now let's listen to the wording here. So this is the wording. It says, write the equation of the set of all points that are a distance of 4 units from 3, negative 2. So write the equation of the set of all points that are a distance of 4 units from 3, negative 2. It sounds complicated. Just the wording may make no sense. But if you think about what it's saying, and you think about the diagram, it kind of does. When you look at number 4, what kind of figure are you looking at when you read number 4? Find the equation set of all points that are a distance of 4 from a point. Huh? If I asked you to draw a picture of this, what would the picture look like? A circle. That's the definition of a circle. Remember, the definition of a circle, when you're defining a circle is a set of all points that are the same distance from a set point. So here's your set point, which happens to be the center, and all these distances are the same. That's a definition of a circle. So this 4 that's listed here happens to be what part of this diagram I've drawn. This 4 happens to be what part of this diagram I've drawn. The radius. This 3, negative 2 happens to be what part of this diagram I've drawn. Huh? The center. So when you're writing the equation, you're writing the equation of the circle. So you know that the equation of a circle is x minus h squared plus y minus k squared equals r squared. So what is the center in this example? 3, negative 2. So your center is 3, negative 2. So there's your h, there's your k. Your radius is what number? 4. And you just substitute all that into your equation. So you get x minus 3 squared plus y minus a negative 2 squared equal the radius, which is 4, but that has to be squared. And so therefore the answer will be x minus 3 squared plus y plus 2 squared equal, and then what, 16? And that's it. Okay? All right, so that was that circle. So that should give you enough examples to get you through those worksheets, at least some of them. All right, now the next thing I want to do is to remind you in your test next week, you have this idea. Test number 2. And I'm going over this because 2 weeks ago when you turned in that worksheet, some of you had some conceptual ideas that were incorrect. So let's look at this absolute value inequality. So I've asked you to solve the absolute value of 3x minus 2 is less than 5. The correct way of solving this is one of 2 ways. So now I know you hadn't practiced this in a while, but those of you that may think you remember, how would you rewrite this absolute value inequality the correct way? You remember?
Split it into 2 different problems. We got an absolute value. With the second one, you flip the inequality.
Okay, now remember, right, and so when some of you turned in that worksheet, you left some words off. What word must I use if I do that? And. The word and. This is a less than, right? less than. So when you think of the word less than, look at that last two letters, A-N. So think A and D. You must use the word and when doing a less than inequality. So there is a difference. There is a difference between this. X is less than 4 and X is greater than 0 versus X is less than 4 or X is greater than 0. The inequalities are the same, right? It's just the words are different. Those two things, the solutions are different. The solution to this one is not the same as the solution to that second one. The word and or tells you what you're looking for. And means intersection. And means intersection. Or means union. So using the words and or tells you whether you're looking for an intersection or whether you're looking for the union of anything that's shaded. So if you look at the first one, let me go ahead and just do that here. X is less than 4 and X is greater than 0. So if I graph X is less than 4, here's 4. And so that's going to be an open circle going to the left, right? And if I do X is greater than 0, here's 0, and there's going to be an open circle going to the right. What are the solutions to that original compound inequality? Where those two graphs do what? Intersect. That's the solution, where the two graphs intersect. So the solution will be this graph, 0, 4, open circle, and shading and everything between them. That's the solution in terms of a graph. If you look at that second one, that or statement, second one here, so here's 4, X is less than 4 going this way, X is greater than 0 going this way. So an or statement means this: the solution to this compound inequality will be either the solution to this first one or the solution to the second one. So meaning that anything that's shaded is a solution. Well, if you look at that number line, what's being shaded? What's being shaded? Every real number. Every number is being shaded. So the graph would be all real numbers. The graph is all real numbers. So there is a difference between the word and the word or. So when you're doing that less than, you have to use the word and. All right, so let me go ahead and do number 1. So on your test Wednesday, you are going to have absolute value inequality. Let's see, it was 3x minus 2 is less than 5. So think less than, A-N-D. So you could break it apart like he said. So you could say 3x minus 2 is less than 5. And at the same time, 3x minus 2 must be what? That's where you reverse. Greater than a negative 5. And then you just solve each of those individually. All right, so let's go ahead and solve each one individually. I'm going to add 2 to both sides. So I get 3x is less than 7. Divide both sides by 3. I get x is less than 7/3. Okay? Now remember what I found, that x is less than 7/3 is a solution to this inequality right here. That's not necessarily a solution to the above, to the original, but it's a solution to this linear inequality. Now let's do this one. Add 2 to both sides. I get 3x is greater than negative 3. Divide both sides by 3. I get x is greater than negative 1. So x is greater than negative 1 is a solution to this inequality here. But remember, I'm interested in the original absolute value inequality. Don't forget that and statement. So now you're going to think about this. So the solution to the original inequality would be any real number that's less than 7/3, and at the same time, it has to be what? Greater than -1, the intersection of those two. So on your number line, graph each one individually. So here is 7/3 right here. Open circle going to the left. Here's -1. Make sure you put them correctly on the number line. Open circle going to the right, and intersection. So you're looking for which part of these two graphs, where the two graphs intersect. So so your answer in terms of a graph will be from what number to what number? Why is it doing that? I don't know why it just went off. I mean, this room is just, I just don't know what happened there. Oh, God. Jesus. It's like someone's playing games with this technology. I don't know how to fix this. I'm gonna probably turn something off. Y'all don't leave. Just won't come on. All right, guys. I don't know what else to do with this. I mean, you can't see anything. Um, and I'll email him tomorrow and see if he'll show up next week. I don't know what else to do but to keep emailing him saying there are issues. I don't know what to do. It's like someone has control of this and just turns things off.
Maybe the Russians hacked the BRCC systems.
Say again?
The Russians hacked our system.
Yeah, it could be. Who knows? All right, so there's nothing else. This thing won't turn on. Okay, but next week, make sure you know how to solve an absolute value less than and absolute value greater than. It's on the study guide. Just make sure you look at that. Okay, so I'm going to have to end it here. There's nothing else we can do. The monitors didn't work. This worked until the very end, and then it shuts off. Okay, let me just quickly call roll. All right, Kelsey, Lindley, Cameron, Nadia, Cassie, Destiny. Okay, thank y'all. All right, the rest of you, Lynn's here. Lynn? Okay, Hannah?
Here.
Haley? Esmeralda?
Here.
Mia? Roland? It's like every day it just keeps dissipating the room. Cleary? Might be easy just to say who's here, right? Lakeisha? Oh my God. Joseph? Kelsey? Oh, finally, I got one. Demetrius here. Entrice is here. Rachel? Hudson? Delaney?
Here.
Michaela? Belinda?
Here.
Jason? Chris? Chloe?
Here.
Kira? Sage? Madeline?
Here.
You was there in that call? All right.
Rebecca.
Oh, okay. Anyone else? All right. I'll just tell the IT person if you went out and see if he shows up. See y'all next week. Well, next week's the test, right? So we really don't need this, but maybe a week after.
I noticed when you went over the assignment, I forgot to do this one by elimination. I just did like the.
Oh, you already turned it in? Just resubmit it.
All right, that's fine.
Yeah, just resubmit it.
Yeah, because I know, I guess I just didn't, I usually always check.
Yeah.
I saw this before, why not?
Yeah, just resubmit. I won't grade it until probably the weekend anyway.
I'll try to get it done tomorrow.
Okay,
All right, thank you.
you're welcome.
Just had a quick question.
Yeah.
The last part you were just showing us, you can solve it this way too.
Yeah, I was gonna do it like that,
Okay,
yes.
Okay, that's
Yeah,
not
no,
what I
that's
was
the
gonna
way that I
say.
did it in class when we talked about it.
Cool, because then I was like, and I was like, oh, I don't think I did
No,
that
no,
way.
no, right, no.
Cool, cool,
Mhm.
okay.
Yeah.
Thank you.
Yeah, I just didn't get to that part. I think it's 1.7.
But I didn't have any mix, so I was just feeling very confident.
You finished? Oh, you did good enough?
I feel like I knew what I was doing. Then two of them, I just completely forgot how to do and
Yeah.
lost to me. But I've been working on the Newton Alta stuff, so that should help.
Okay.
Yeah, thank you for giving this extension.
Oh, you're
I really
welcome.
appreciate it.
Sure. Anytime.
My life has kind of been eased up a little bit, so I
Yeah.
can focus more. on
Make sure you
getting
study for the
done.
next test. I gave you all the study.
Yes, yes, thank you for that.
Okay, so that way it's fine. Okay. Nope.
You know, he did the end statement, the way we did class was together,
Right.
but,
Some people did it different on the test, so you need to talk about
yeah,
it.
so if we had time, the same was working, I would have done it that way as well.
Okay, okay. I'll go back and read it.
Secretary, thank you.
You finished? Okay, come. No, you can come. Well, I'm done.
Not done?
Yeah, I'm done.